Hi, today we are going to be learning about how to solve a problem with an elapsed time problem, and we are going to be learning how to solve it with a linear model. So I have this problem right here, and it says Amy will take a test at 2:30 p.m. It is 10:50 a.m. How much time does Amy have until her test? So like I said, we're going to use this linear model, and it's going to help us represent the length of time that elapses. So in our board problem, it starts at 10:50 a.m. and our end time is 10:30, but we need to find the time in between those two times that elapses and figure out how much time does she have until her test. So I made this little linear model chart right here. And I started it off at 10:50 a.m. and I put a little reminder that a.m. means before noon down here. So we end at 2:30 p.m. and like I put down right here, p.m. means it's afternoon. So anytime before 12 p.m. is our a.m. time, and any time after is our p.m. time. So I need to get to 2:30 p.m. from 10:50. In order to do that, I'm going to take a tiny jump of 10 minutes from 10:50 to 11. And I'm going to do that because it's easy for me to start this way and to be able to jump throughout the next to 2:30. So I just jumped 10 minutes from 10:50 to 11. So I still need to be able to get to 2:30. I'm barely at 11. So if I jump, to make things easier, if I jump all the way to 12 o'clock, that's going to be 60 minutes. And 60 minutes is equal to 1 hour. And I want to be able to jump that far because I don't want to make tiny jumps, because that would take a long time. I want to be able to group all of that together and jump all across and make a 60 and make an hour, and that would make everything very easy to do. So I jumped all the way to 12 o'clock, but I still need to make it to 2:30. So I'm going to make another jump from 12 p.m. to 1 p.m. and that's another 60 minutes right there. So a common misconception whenever you cross that 12 o'clock, either a.m. or p.m., students are always going to get confused and always want to count from 12, 13, 14, 15. So if you have students that do that, the best thing to do is to provide them with a little clock as kind of like a manipulative, and use that to help them know that time always just we don't go past 12. So that would be a really good idea to help them get over that misconception. So going back to the problem, we stopped right here at 1. We're almost there to 2:30. So from 1 to 2:30, I can make another jump, another 60-minute jump. So I'm going to do that, and it's going to fall right about right here. And that's our 60 minutes. So, and that's at 2 o'clock. We landed at 2 o'clock. But I still need to get to 30 minutes. So I kind of already made it easy on us. And I know that if I just add 30, I would be right there at 2:30. So I'm going to make that 30-minute jump. And now I need to find out how much time elapsed. So we have 10 minutes, 60 minutes, another 60, another 60, and a 30-minute. So how can I be able to find out how much time elapsed from 10:50 to 2:30? So to be able to solve this problem and to find out how much elapsed time that we came across, I'm going to add all our minutes together. So we know that 60 minutes equals 1 hour. So I have 1 60-minute, 2 60 minutes, and 3 60 minutes. So this is our first 60 minutes, our second 60 minutes, and our third 60 minutes. So I have 1, 2, 3. Right now we're at 3 hours. So now I'm just left with 30 minutes and 10 minutes. So to be able to add 30 and 10 minutes, we're just going to set it up just like that. I'm going to bring down my 0, and I'm going to add my 2. My 3 and 1, and it's going to come out to 40. So this is 40 minutes. So we now know that Amy has 3 hours and 40 minutes until her test time.